Hello, everybody. I'm your host, and welcome to Securing Open Source Best Practices. My name is Mike Vizard, and we have an awesome panel today. But first, let's get into some housekeeping. I want to direct all your attention to the chat window on the right-hand sides of your screen. This is where you can engage with us, ask questions. We'll be monitoring this during the course of the show. And then at the same time, we also encourage everybody to stick around because there will be some Amazon gift cards at the end. So the winners will be announced in the last, minute and a half, 2 minutes of the event. Let me introduce our panelists today. They are Peter Albert, who is CISO for Influx Data. Peter, welcome.
Thank you.
We also have Julius Mousseau, who is CTO for MergeSpace. Julius, welcome.
Hello.
We also have Sherry Itzan, Director of Product for White Source. Hi, Sherry.
Hi, everyone.
And we have Florian Coata, who's a Product Manager for HCL AppScan.
Hello, everyone.
And then finally, we have Curtis Barker, Vice President of Product Strategy and Field CTO for Resilient.
Hi, nice to be with you.
All right, we're going to do something somewhat antiquated here, but we're going to do ladies first. And we're going to ask Sherry a question, which is, how serious or how big a problem is open source security right now? And I'm asking the question because I get there's a lot of vulnerabilities. However, a lot of folks in surveys are saying they trust open source software more than they do proprietary software. So what is the extent of the challenge or the issue right now that we're looking at?
So this is definitely interesting. I would like to start with, today you don't really have a choice in terms of, business-wise, whether you will use open source or not, right? Let's put security aside for a second. In terms of the business benefit it gives you, the velocity that it gives you, right? Everyone talks today about agility and how important it is to keep up with the market. This is one of the greatest enablers for that. So we just wanted to set like the scene that open source is like, it's not even the future. It's here and everyone uses open source. Even some companies that don't know they use open source. And in terms of the challenge or like the security threat in open source, so I think that like 3 or 4 years ago, someone asked me like, what is more dangerous, using my own code or using open source? And this is a question that rarely comes up now. There are a lot more vulnerabilities in open source, right? We usually see that the developers that are developing open source are sometimes less experienced. They don't get the right security training, which exposes us to vulnerabilities. On the other end, we see that the community in open source is so much stronger. And almost every time when a security vulnerability is being published, I would say like 95% of the times, the next version would already have the fix, which means that if you maintain your open source components up to date, which is not an easy thing, by the way, you are more or you are less in terms of getting, yourself to a risk. So the downsides, of course, are I don't know who wrote this code. I don't know how well this is maintained. On the other hand, if you use components that are that are not deprecated or that are being well maintained, you can be pretty sure that if you secure yourself and if you make sure that you scan your code, etc., you will be safe by upgrading to a later version. I would say that for now. But of course, there are a lot more parameters to how you secure your open source. But just in terms of setting the scene, I think that's more or less the basics of it.
All right. Peter, I'm going to jump to you for a minute. Do you agree with that? Is open source less secure, more secure? As a security fellow, how do you see this playing out on in production environments?
It's very contextual to how you're using the open source in your environment, and also how much rigor you've put into evaluating the open source components that you're using. So I agree, it's a pretty broad spread problem with a lot of complexity and a lot of scale. There's sort of a logical interpretation, which is the more people who look at the code, the higher the probability something will get discovered and discussed publicly.
Do you think there's a kind of a flip side though, like an increased vulnerability there, in that with open source, right, a malicious researcher is more likely to find something good because this is a very popular library, it's used in thousands of companies, maybe if I just research it really deeply I'll find a good vulnerability there. Like, do you think there's more exposure because of that?
That principle I think applies to all software. I mean, if something's very popular, then a malevolent researcher will want to target that. But getting back to if it's open source and more people are looking at it, there's a probability that vulnerabilities might be disclosed. That itself can also be a fallacy. And I wanted to cite the work of a researcher, Ilya von Sprundel. And I believe it was 2018, 2019. He did some research on BSD. He looked at maybe 10 different distributions of BSD with the idea that this has been open source for a long time. So in theory, it should be pretty solid. But quite to the contrary, he found that since it was open source, there was an implicit assumption that it was secure. And he found hundreds of non-trivial vulnerabilities across multiple distributions. Particularly if it's a large code base, where if you've got 7-8 million lines of code in an open source package like an operating system, maybe there are some things in there that people just haven't gotten to really looking at and understanding.
Florin, do you think that we're about to discover more of these because we had some software supply chain incidents? We've had the Biden administration issue an executive order, and there's more people looking at their software supply chains and maybe discovering that they have all this open source software they didn't know about before.
I mean, to say that we're not going to find vulnerabilities, it's, would be the end goal. I think that's the end goal of security, saying we'll never find them. I think we'll find more vulnerabilities. I think the important thing is how do we handle that and how do we work with the process of making that information known, and how do more people get into this space of, hey, let's help the open source community to get more information about their vulnerabilities. So let's supply them with the tooling to do. And we see some great initiatives that are being started for open source, allowing them to find more stuff, giving them more tooling to use on their projects, from security tool vendors, from development shops, making sure that open source gets the support it needs to go through that process of training their developers in some cases. And when we say open source developers, it can be everyone, but there will always be a core of people that will hopefully maintain the project. And yes, we will find more of them. We're probably going to have another big set of vulnerabilities coming over the next few years. Which one were the big ones? The Hardbleed, the shell shocks. We will get more. And supply chain is adding some interesting twist where there's some more complicated attacks that could come through. But I have faith that we will, at some point, overcome the problem. There will be some costs, let's say, along the way. Some people will be caught off guard, but I do have faith that the open source community and these communities in general have that feeling of pride, and they do want to do their best work. They do want to put forward their best commitment, which is something quite interesting about open source on itself as a mentality. It's a very interesting project. No one's forcing them to do things. No one's forcing them to kind of get invested into this software development, but they do it out of passion. And I think that will help them also focus more on security in the near future.
Curtis, do you agree with that? Because I've talked to some developers and their attitude's a little more, shall we say, less enthusiastic for what Florin just said. What their argument is I built this fabulous software for you. It's free. It's open source. I did all these things, and now it's your responsibility, if you care to use it, I'm not making you use it, to secure it. So where is the onus on the securing of the open source code supposed to be? Is it really with the developer, or is it with the people who are deploying it?
It's with both, isn't it? And yeah, I think there's some studies out there that say that developers participating in open source communities spend 3% or less time working on security as a part of the development process for open source. So it is a small amount of time. I think the focus is about creating usable, functional code, and there is a large volume. So even when we throw out numbers like that, it depends on the size of the project, the participants, the follow-up, the velocity of development on any one particular project. I agree, they're very proud of what they're doing, but what they're doing is a focus security. And I'd argue in the past it hasn't been. I think it is more and more, but we can't take that for granted. Hence, organizations using code that is open source need to, one, be able to identify that they are using open source code, open source packages within proprietary code, and then two, understand where that came from. And I think some of the executive order that came through from the Biden administration is helpful in that regard, because it does require you to produce a software bill of materials and ensure the integrity of it via automated tools, and then check for remediation for potential vulnerabilities via an automated tool. So I think that leads organizations to be responsible for understanding, what code they have, what portion of it is open source, and then to check the integrity of it. And of course, we'd love these projects to focus more on security, but we cannot take that for granted.
I have a funny anecdote about that. About should the developer be responsible or the end user be responsible, or the person bringing open source into their org? Where when I was at a credit union, we accidentally would send the full deployment off to Veracode, which is a SAST tool. And so in a way, including all 300 open source libraries in the product. And so Veracode was analyzing all 300 open source libraries every night, looking for SAST issues, and so we would have tens of thousands of these vulnerabilities that Veracode is discovering in the open source libraries, but we just, we're too busy to even forward those to the open source libraries, right? It's just like a credit union trying to make sure the online banking is okay. It's kind of funny that, oops, we were accidentally running SAST scans against the open source libraries.
And I think that is an interesting concept, because we do see people asking, we do see end users, kind of companies asking, hey, what if I do static dynamic on these libraries? What can I get some information out of them? The challenge is a lot of the tools will produce results, but results need to be interpreted. And I think that's where the community is really strong, because if we just deliver this kind of information, hey, I scanned this open source library with tool X, here's the results, they might not have the means to be able to decide if those findings are real or not, and we're just adding more work to them.
We have a bit of activity on the Q&A too, which is worth looking at here. But sorry,
what Curtis was saying, 3% of developers' time is spent on security, which is good. But what we also have to take into consideration that there is an open source security community. There is a series of researchers and white hats and pen testers, and I don't want to say that their goal is to break these things. They do like to see their name next to a CVE disclosure. They do like to be there, and they do contribute a lot. And they don't do that for closed source projects. Research communities, you do see them working with closed source sometimes, and they will disclose stuff. But to what Chris was saying, that there is a security community that's really, really passionate about finding things in open source as well.
Yeah, and I'll just add really quickly, Mike, to what Florian said at the initial point. He said, and I hope I'm not putting words in your mouth, Florian, validate the results. And that's really important. There are no end of tools out there that will scan and produce vulnerabilities. But to actually validate which one of the vulnerabilities are exploitable for the code that you're running for your particular application, I think that's really important, because the reality is developers, security teams are already overwhelmed with the amount of security issues that they need to fix generally. So creating, the opportunity to really validate which ones to prioritize based on the exploitability, and then having tools that will be very transparent around where the software, where the components came from. A mix of the two helps out a lot practically in terms of where you're going to spend the time to keep your application protected.
I'd like
Yes, I
to.
definitely agree. I think that's, sorry, again, with the amount of open source vulnerabilities, like Mike, what you actually opened with, right? It's getting, we're getting more and more vulnerabilities, and probably in the next few years we're going to get more. Prioritization is critical. Like the idea of, probably I'm not going to handle all of the vulnerabilities. I'm not going to resolve all of them just because an average application would have hundreds or thousands of vulnerabilities. And I need to prioritize based on what's exploitable, what's really effective, what kind of methods of the open source are being called by my proprietary code, what vulnerabilities are maybe found in transitive dependencies, and I can currently not act upon them. And all these kind of things are definitely things that we're seeing and handling. And I think that most of the tools are doing quite a good job today, both in, being able to determine which vulnerabilities need to be handled first, as well as giving this a business priority, right? At the end of the day, it's all about the business. And in some applications, the critical vulnerability can be really critical, but in some, even a low vulnerability is something that can harm my business. So it's really about like taking all of this information into account and making sort of, a prioritization that is based on not only like the naive CVSS score, but also about like my own business and how it affects that.
I'd like to just address Steve's questions on the Q&A.
Go ahead.
Sure. Well, the first question, Steve, you asked, do you think using a binary repository alone could help secure open source? And I'm going to just have to say, I don't quite understand that question. To be open source, the source code has to be available. So even if the artifact is available in a binary repository, the source code will still be available in its, in GitHub or wherever it's published. I guess, a lot of open source licenses like MIT or BSD or even Apache don't require the source code to be co-published, but nonetheless, it usually is. Your second question, Steve, is you tried to establish a use policy defining what components or source libraries, I guess, people could use in your company. And but then developers found it inflexible, right? And so, of course, you're adding friction to the process whereby a developer can bring a library into the solution. And in many ways that's going to improve things, but it's also going to bring development to a halt if a very useful library or framework is identified and then they suddenly have to throw it into some review queue internally that nobody ever looks at. So I've always been tempted by that question to be like, well, if the library is in Ubuntu or Debian, then you're free to use it, because at least with Debian and Ubuntu, there's a second layer, right? Like the Debian or Ubuntu maintainers at least are reviewing it. They're reviewing it for the license being appropriate, and they are also keeping an eye on security vulnerabilities. So that's kind of like a middle ground that I've always been attracted to.
All right, Sherry, I want to follow up on that with you because we have a question from Christian, and it's kind of a similar idea. But a lot of times when you're a maintainer of an open source project, you're hungry for contributions from anywhere you can find them. But do we need to be more careful about who's making those contributions and have those people vetted in addition to looking at their code? And is that going to be a bigger issue? Because it seems like nation states are now trying to weaponize some of these open source projects.
Yeah, so I think that that's a great question. And really, like, we had a lot of discussions in the past. I mean, are we going to like completely, give like a scoring like in GitHub for each and every one of the maintainers or the contributors, and based on that say whether the open source is secure or not, and all kinds of things. Also, one of the things that I heard in one of the previous webinars is like there is not enough money in open source, and like some of the contributors are really working for like great companies, and this is their motivation, right? They're contributing to open source, but they're not doing it voluntarily, but maybe, giving some more means for developers to actually write open source would benefit in terms of the security. I don't think we have the answer today. I mean, I think that definitely it's all about reviewing, right, the pull request and making sure that we have the right code review and the right maintainers. Also, as we mentioned before, the open source community is very, very strong. So you can assume, again, putting aside malicious packages and stuff like that, you can assume that if a specific repository has enough downloads, enough commits, enough forks, it's probably safe to use. And currently, I don't think that there is a good solution on actually verifying each and every maintainer or each and every contributor to the open source, but I'm happy to hear otherwise again.
Yeah. Well, Florian, let me follow up with you on that. You were talking a little bit about there's an open source community for security, and a lot of times it's vendors who are contributing code to these open source projects. If you delve into there, you'll find people from SAP, Oracle, Microsoft, AWS. So should those folks be devoting more of their resources to security because they have, at least the argument is, they have the skills to do that versus your average everyday contributor?
It's a hard one to answer, because saying that they should allow more time for security would imply that they don't. And a lot of the people that do contribute do kind of do the due diligence. So we'd like to encourage that. We'd like to see more people contributing more and helping more with security. But I don't want to say, through my answer that they're not doing that already. It's something that's very hard to measure. One of the things that we constantly hear when you deal with static analysis is, how secure is the code that my developers write? And it's a hard thing to measure, right? It's a hard thing to monetize security when you do the right things, because all of a sudden there's nothing to worry about. But we do hope that people that work from all aspects, small companies, large companies, and do contribute to open source, do take some time to do some security, do ask for help. And I think people at larger companies can potentially get some more help. They can get their own security research teams to maybe get involved in those packages. So we definitely want to encourage that. Encourage, research teams and security teams to look into the open source projects you're contributing, see if there's anything there. And a lot of the times, if they are working for a large company and they are contributing to open source, I think it's fair to say the equates that they are using those components. We've seen in the past, the Red Hats, the IBMs of the world, a lot of contribution to open source, and they do actively use those projects. They do work with them, and they do perform security research on them as well. But we want to encourage them. I don't want to accuse them that they're not doing it enough, because I don't know the stats there, but we do want to encourage that as much as we can.
I had an open source library that I maintained just by myself for like 5-6 years. The only patch I ever got was from Red Hat, and it was fixing a security vulnerability. So kind of supporting Florin's anecdote there.
All right, maybe we just need to get those guys a little more organized. Julius, we were talking about SBOMs earlier, and I wanted to get your opinion about something. It seems to me, at least in the age of containers, that the software is constantly being updated and we're ripping stuff out and replacing it. So the SBOM, is it really descriptive of what's going on in there, or can we continuously update that? And does there need to be some sort of process for doing that?
Well, right now, like I believe if you want to sell software to the U.S. federal government, you need to support SBOM. As a vendor selling into the U.S. government, and I believe other companies and governments are going to follow suit on that if they haven't already. So I mean, there it really becomes a moment in time thing, right? Like I guess you should be able to query any running application for its SBOM right in that moment. That should solve that with all those constant updates. Another question though becomes like, I mean, if you ask a Docker image for its SBOM, there's tools out there that will tell you all of the packages that are currently installed in that Docker image, like what version of Postgres, what version of SSH. But they don't look deeper than that, right? Like they don't go into the libraries of the individual of those systems, right? Because on a Docker image, I can type apt-get install Jenkins, And so now the Docker's SBOM is going to say, yeah, you've got Jenkins, but is it going to say that I have Guava, the Google library that definitely comes with Jenkins? So I feel like SBOM is it needs to go deeper.
Yeah. Shiri, we talk a lot about shifting left. Do you think that a lot of these security issues are going to be uncovered as people build their applications using open source components during their DevOps workflow or DevSecOps workflow? And maybe we can lean more on the platforms to discover these issues versus the developer.
Yeah, so I definitely think again that developers don't have to work in security, right? They need to develop applications, they need to do their job, they need to develop new features. As a security vendor, my goal eventually is to minimize the time that developers log into the platform, handle security vulnerabilities. I want to do it for them. So everything that we can automate, we need to automate. And another important thing is that we need to integrate into their existing tool. And a great example would be like the repo, right? If I already write my code in the repo, in GitHub, let's say, and I'm doing a code review process, and I just added a new open source library that added 2 vulnerabilities, this is something that should come up in the code review, right? It's my responsibility because I just added this open source component. Maybe I can look for another component, maybe I can just upgrade the version that I'm using. But anyways, this is something that currently the developer needs to give the answers on. They need to be aware of it. Eventually, definitely, we wouldn't want it to be this way. We would want that even, as part of the research for adding a new open source component, I can see what vulnerabilities there are in it, and then maybe have a better component that is more maintained, that doesn't have vulnerabilities. So this is like the extreme shift left. Overall, I definitely think it's a process, right? So from, people scanning in the pipeline, failing builds due to security vulnerabilities, which is something that is not very agile and very smooth, right? Because it stops everyone. To the moment where we already find the vulnerabilities earlier in the life cycle, like as part of the research in the IDE, or even in the repo integration, that's even better. So yes, definitely.
Curtis, how smart are the tools going to get? And I'm asking because David has a question here about educating developers. We also need to have the tools that will help us identify the library being used within a specific project. But it's not clear to me that even if I know the library, that I know what the vulnerabilities are per se. Or so, how do you see this coming together? And how do you see? We hear a lot about DevSecOps, so I'm kind of asking, what's the process going to look like?
Yeah, a great question. And the tools do need to get smarter to some degree, or they need to they need to get more cohesive in the way they work together. Because a lot of the information, a lot of the tooling to solve these problems are out there. Do they all talk to one another? Are they all automated? Not necessarily, and I think that's what the market is demanding. And similar to Julius's comment about SBOMs, actually most SBOMs are manual today. People produce manual SBOMs, right? So we can do a lot better. But when you think about, to answer your question directly, yes, the practice of DevSecOps and the automation you get with that is really important. There's still a lot of organizations, of course, with fairly immature programs, but that shouldn't stop them. They should have a roadmap to try and embed DevSecOps practices. And what studies see regularly is that organizations with more mature DevSecOps programs are 2 to 3 times more likely to be using automated security tools and scan more frequently during the development cycle, which helps drive faster fix times. So that's really really an important part of that as well. That the more you're doing it, the more it's part of your process. The less technical debt you need to worry about as well. A reduction in technical debt. Most applications have flaws. There's a general build-up of security over time. So if you're building it into a process and iterating faster and more agile, there's less of that build-up. You can address things more quickly, and there's also, a lot of studies that say if you don't address things in the first few months, that debt will stay there over time. So building in practices, from a people process point of view, but using technologies that can work together to provide the right level of information is really important. And going back to SBOMs, that's a good example. Most of them are not dynamic today, right? They're a point in time snapshot. I think, when you look at SBOMs, to make them more practical and usable in an environment that we're in now, where code bases are regularly changed on a daily basis, sometimes many times a day, we need dynamic SBOMs that reflect the code as it's changing over time. And to the question that was raised, we need some level of validation. It is helpful to validate of your SBOM what is in use as part of that SBOM. Again, allows organizations to kind of prioritize. If I've got something in use and it's at risk, it's probably more important than the stuff that's part of the code base but isn't used, number one. And two, if it's not used, do I need it? Right? So I think, there's a number of different benefits you can get there with that level of additional context around an SBOM, for example.
Florian, let me ask you this. I talked to some developers and they're inconsistent on their scanning at best. And part of the reason is they think they're going to write code, and instead of scanning a small amount of code, they let it sit. And then suddenly they've got this massive build at the end of the week somewhere that they're supposed to scan. And then it's going to take 6 hours to scan, and inevitably it fails. So is there some better, smarter way to think about scanning here? Is this really a human issue rather than a tech issue?
Well, I think it can be a bit of both. So to what Curtis was saying previously, he was talking about automating and how automating is important and how that can help. But I think it's really important that we allow developers to become self-sufficient, and we need to establish some level of trust between security and development teams. We're talking about DevSecOps, but realistically, we're looking at DevOps team that have a security person somewhere centrally, but those teams don't have any security capacity themselves. So to go back to your question is how they should be doing things if there's a smarter way to do things. One of the ways we've seen working quite well is enable development teams to have their own security specialist. You don't need someone who understands security at an advanced level. You just want someone who understands some security best practices. And then they can find a model that works for themselves. They can scan it as they type their code. There's tools for that to help you find things immediately. Or you can do a scan at the end of the week. Different teams work in different ways, and I don't think there is one solution that works for everyone. We've seen teams that are very efficient with dealing with security debt at the end of their release cycle. So 3 months in, they'll do their security scan, but they know 2 weeks for me will be security. Nothing goes out before I finish this work, but they're very efficient with what they're doing and the way they're doing it with. The one thing I would also mention here with should I let things pile up? My anecdote to this one is whenever you're doing security, you tend to think, hey, I'll do security 3 months in. But think about security issues like emails. If you don't answer emails for 3 months, there's going to be a lot of emails to go through to sort them out. And security will be the same. The longer you put it off, the more things will add up and you'll have to review. Tools will not produce 100% accurate results. One of the things I like to say is no tool will produce vulnerabilities. They'll come back with findings. Someone has to look at the findings. Surprise, surprise. Security team will not have time for it because you're 3,000 developers and 30 security people. So that's where I think that enabling development teams to have some security knowledge themselves and allowing them to set up a process and give them the kind of the expectations can be quite efficient. If you tell them, here's the policy, I don't want to see any open source high or medium vulnerabilities. I don't want to see any high vulnerabilities coming from X and Y tool. I think you can be quite effective with that, and they can find their own style. I would love to be able to sell a story of this is the perfect way to do it, but we've seen the story being changed in so many different ways by different people, and it works for them.
Yeah. Well, Peter, let me ask you this because you're on the CISO side of the house, but what exactly should be the role of the security team in this conversation as it relates to developers? Because to Florin's point, developers are outnumbering security people 10 to 1, and security people have their hands full. So, how do I bring these two cultures together?
DevSecOps implies a different security model organizationally, which some companies call the distributed embedded model, where security engineers, as Florin represented, are embedded within development organizations. And there can still be a central security team that helps provide training, oversight, and larger order programs. But you really need to have people within development, and you need to educate developers. I think that's probably one of the most important controls that we found on the scale of the issue, what the tools are that are available, and what the life cycle should be when thinking about using open source and when receiving a report that there might be something wrong with it. I think, as Curtis and others have said, there's a bit of analysis that has to occur to determine, not only does a library have a CVE, but is the method within the library one that I'm using? And then ultimately, does that make it into the binary? Just because it's specified in code doesn't mean it made it into the binary. A lot of times things can get optimized out or changed. So there's multiple places in the delivery pipeline where introspection and observability is required.
Hey, Curtis, can I ask a question as a follow-up? One of our attendees here is saying that his problem is that the security team doesn't want to be involved in setting up the policies or the best practices, so they've been kind of winging it. Are there places to go get policies that people can implement so maybe they don't have to wing it so much?
Yeah, there are lots of guidelines on, that will help inform policies from, the likes of NIST and MITRE. There are a bunch that look at DevOps and DevSecOps specifically. So there are guidances out there, but, any practitioner in the space needs to take a look at what's going to work in their organization, get alignment, and then try and drive those policies. And it would help if the security team helped to kind of rubber stamp and worked with the development organization. I'm surprised by the comment that the security team are not partnering with that organization that wants to create a security policy. Usually it can be the other way around. That's what I've observed, that the security team are trying to create a policy, and then the policy, for whatever reason, is problematic from a business development perspective. So the fact that whoever's in this security team, they've got a willing audience that wants to work with them on a security policy, it feels like, Christmas come early. They should take full advantage of that. Yeah, but yeah, there are numerous places where you can get guidance, but actually creating a security policy that's going to work in your organization, it's going to take some curation.
All right. Well, speaking of that, we have another question from Christian, and I see that Florin playing
Yeah.
around with it, so it's going to him.
Can add something to what Curtis said, and to
Sure, go ahead.
one of the things we've seen being quite effective with this, there's often the question of who's responsible for security. And one of the things we've seen, one of the security people we've been working with was having a different problem. Developers would not respond to the policy. They said was, okay, it's a simple job. We're going to go to the next person up and we're going to say who gets fired if we get hacked because we don't have this. And the answer was simple. Do you have the security policy? Yes. Security is good. Do you provide them with the tool and the education? Yes. Developers, are you signing up to be responsible for those guidelines that have been given to you? And they're like, well, it's not our job to secure things. Obviously, the management disagreed, and that was a simple break. But always ask them, who's responsible for it? If they're saying they're not responsible, fair enough. Take it up to the next person in the chain and make them kind of do that split. Make them do a judgment for you. You should, if you want to do security, you should be very, 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 clear about it that you want to do it. I don't think it happens often enough that developers want to do security. We should encourage that by all means. Go to the next person up in the chain, escalate. You should be allowed to do security. You should be enabled to do security.
Well, follow up on that with our next question from Christian, who wants to know more about AI. So, how far can I kick the can down the road? Can I kick it all the way to an AI that's going to take care of all this stuff someday, or can this save us from ourselves?
My favorite story about security is a tech company that thought we're going to build an AI agent to help us with code quality. Does anyone want to guess the outcome? It did to their code what Skynet planned to do to humanity. They basically deleted the entire code base. There are ways you can use AI for code security. Absolutely. I think there's a lot of different technologies and a lot of different vendors leveraging this out there. For static analysis, my engineering team has been using AI to help us discover new ways of tracing code through the applications. I think in some other cases, people use AI to recognize what an effective fix would be for you because they can see other people doing that through open source. Going back to that open source, they can see through the pull request what was done. Uh, AI is just another tool in the box. I don't know if it's the end goal for it, but people are definitely leveraging AI at the moment. There's different creative ways of using it, and results can be quite impressive at times.
Right.
And
Sherry,
if you are happening to launch or found a cybersecurity startup, if you can somehow inject some AI into that a little bit, it does help attract investors and improve your valuation.
all right. Well, Sherry, let me ask you something here.
You've got to be really, really careful. Just to follow on from what Julius and Florian are saying, is that in a fast-paced DevOps environment where code changes and code changes in your code base frequently, the model which AI is taking a viewpoint to then inform its decision-making process, it's changing very quickly. And when you've got a model, a data lake that is rapidly changing, AI can be very inconsistent, right? If you've got a stable data lake, and then you can use that as a way to inform decision-making process, that's useful. But in a very dynamic environment, one of the reasons why we've seen probably less AI than in, for example, the XDR space, where there is a bigger data lake, is because of precisely that. When I've seen vendors use AI for things like preventative measures or detection, there's lots of false positives because in a dynamic environment, things change too quickly. And then to follow up on one question raised by William here in the chat around containers that come with a lot of open source component that contain vulnerabilities. My organization did some testing on again the top containers used in the Docker repo, and a lot of them do have vulnerabilities, significant amounts of vulnerabilities. What we were able to test and validate was that only 30, sometimes only 20% of them are actually exploitable, meaning that when you use those images, the vulnerabilities associated to those packages are not used. They're not in use. They're part of the file that it comes with, but they're not actually in use by that Docker image. And that's why it's really important to validate if the image that you're using, validate if the vulnerabilities are exploitable, if they're going to be running through memory or not. And if they're not running in memory as part of the runtime execution, then they're not exploitable, right? So that validation can save a lot of time and help you have a much better baseline of risk.
One problem with that, though, like if you look at the Equifax Struts disaster, in that case, the library is just sitting on disk, right? It was never in memory. The problem was that the attacker could compel the library to load and then attack through that. So the actual vulnerability was never used. It was only the attacker that was able to compel it into it being used.
Yeah, but that's a great point. So you will have scenarios like that, which is why it's important to have a dynamic, SBOM or anything that's scanning, to have it scanning dynamically. Because what you're saying is there was a scenario where something not in use was provoked or
Yeah.
invoked to be in use. But
Yeah.
once it is in use, it can be marked as loaded. And if it
Yeah.
was loaded, it can be loaded. And if it has been loaded, you should mark that as something that is risky and then treat it accordingly. But yeah, you're absolutely right. There are techniques like that out there, which is why having a dynamic process monitoring what actually is executed in memory is really important.
Sherry, is there some way to cut down on the number of alerts being generated without maybe getting into AI? I mean, a lot of people may not be ready.
So yes, and this is, I think, one of the things that is something that I deal with like on a daily basis. Like, how do I reduce the noise? How do I make sure? Because if there are so many vulnerabilities, no one is going to treat them, right? If you open your alert screen and you see like thousands, you're not going to do anything because you're going to say, okay, it's not going to happen. It's not going to help anyway. So the ways that we currently use to reduce the load again is identifying what vulnerabilities are effective, being called by your proprietary code, which is not an AI technology, it's an algorithm, but it's there and it can be used. Of course, making sure that your dependencies are up to date all the time. So every time there is a newer version of the open source component, make sure to use that. And
Say on
there are
that,
great.
Sherry, with that though, with always making sure you're on the latest and greatest, right? Like, then you're vulnerable to those other attacks, like Event Stream, where the poisoned package gets released. So what do you do about that then?
Yeah, so I think it's a combination. Again, it's not just having one of these tools and that's it. It's also about maintaining, making sure that you don't have and blocking these kind of malicious packages. We also use, like data and crowdsourcing technologies to understand that sometimes it's not good to use the latest version, right? Sometimes the latest version was not adopted by anyone and you are the first one going to use it. You would probably not want to use it, right? So seeing that data, seeing what is the confidence of the merge that you are going to do is also a very important thing. Knowing whether other GitHub repositories already adopted this change, but they rolled back is a great signal for, okay, I don't want to update to this version, even if it solves a vulnerability. So having this kind of data really reduces like the noise and also reduces the risk. So these are just two small things that we can do in order to eliminate or make sure that the number of alerts is smaller. Again, this is a great question, and I think this is definitely something that security tools will need to address, right? It's not only about showing you the report with these are all the vulnerabilities, even there if there are zero false positives, which by the way in open source the situation is very good. I mean, it's not like static analysis where you have to review the results, and there are a lot of tools out there that are sometimes you have to work and make sure that you fine tune the results. With open source it's pretty easy. This is why it's also considered by a lot of people as a quick win, right? You go through the results, they are usually accurate and you fix them. Of course it's not that easy, but this is another difference between proprietary code and open source.
Yeah, I don't know if everyone's quite catching that, but in a way, what Sherry's saying, I believe, I might be mis paraphrasing, is SCA tools are nice, like White Source and Mergeface, for example, as SCA tools, and Florin has an SCA tool as well, in that they tend to just not report as many vulnerabilities, whereas SAST tools, static analyzers, just drown you in alerts, like tens of thousands of alerts, whereas SCA tools tend to really just focus on vulnerable library versions, and so they don't drown you like that.
Absolutely. One of the advice I always give to my clients is decide what you want to do and focus on doing static analysis on your code and SCA on third-party code. You can do SCA on third-party code. Do you want to do it? If you're a security researcher, yes. If you're a developer trying to secure your stuff, probably no. You have to validate things. And if you don't understand that code, it's very hard to do. We've seen developers being quite effective at becoming security champions through static analysis. because they kind of start getting into the mindset of, hey, data comes from this place. It's a user input. It goes to this place. It's a database. Am I seeing any form of protection in the middle? And is there any sanitization happening? So we've seen these tools being effective, static analysis, in training developers to think more like a security person, but convincing them to do it can be a challenge at times because there is a bit of work you have to do. And nothing applies more than the email story to security than static analysis. If you don't do it for 3 years and you start, you'll be busy for a while, but you can get there. And these are places where AI can help. There are some smart ways of dealing with the data that can help. But as always, it does require some effort to get there. And my firm belief is that no tool will ever report vulnerabilities. At this point in time, they will report findings. It's up to you how do you fine tune the tooling and how you create your own funnel to get to the things you care about.
I think there's an opportunity there also in the contemporary software development pipelines where there is typically a kind of a peer code review step, which more traditionally is done for things like stylistic and functional reviews. So taking advantage of the existence of a manual code review opportunity by offering focused training to developers by security researchers on what they look for when doing manual security code reviews, just to have that baked into the knowledge of each developer. Then when they go to do that manual peer code review, they might have a higher probability of discovering something that's worth discussing.
Yeah. Hey, Peter, Christian is asking if the bad guys are starting to use AI for penetration testing and to discover code, and are we involved in something that might feel like an AI arms race?
I believe that's been happening already for some time.
All right. So is there
AI is a tool like everything else, right? It's a stepping stone towards automation. The purpose of AI is to remove some of the noise from us, declutter some of the things. But at the moment, personal belief, AI is not the final answer to it. It's just another tool we have in our toolbox. And I think Curtis raised a good point that AI has to be trained, and training AI is not always easy. AI can become biased if you don't train it properly. So as always, we still have responsibility to do things, but AI can be a very efficient stepping stone towards getting in a more secure place.
Peter, let me follow up with that. Do you think there might be a backlash against open source because of security concerns?
No.
Again, like I have a hard time ultimately drawing much of a distinction there between the use of open source or enterprise. If you're using someone else's code, there's a possibility, if not a probability, that there's something in there that you should know about from a hygiene perspective. Whether or not it makes it into an exploitable situation is a whole other story. So I don't think open source will receive any type of backlash other than what third-party software in general is receiving. I think going back to, was it Richie who said, if you didn't write it, you can't trust it? Right? Ultimately.
He's made a mistake there. I don't even trust my own stuff.
Fair enough. Yeah.
That comes on to a question.
I'm going to go around to everybody and ask this following question, starting with Shiri. Okay. Are you optimistic or somewhat pessimistic about the state of open source security right now?
I think I'm very optimistic. Again, I think it's all about risk management, right? Like, what is the value that I get out of open source versus what is the risk that it poses on my organization, and how do I manage that risk? And I think that we can definitely see, in terms of just in general, like the velocity that it gives to enterprises and to organizations in general, the ability to open new businesses, new startups, just, with that code that you already have, and leveraging open source is just a great thing that we have. And I think that with the evolvement of new security tools and existing security tools to be more automated and more even like invisible for developers, we can definitely like continue and leverage open source. And I think I definitely think open source and the open source community is a great thing, and it enables us just so much.
All right. Anybody feeling pessimistic about the future of open source security? We have a room.
Open source is humans sharing knowledge with each other. So, we just have to get a little more rigorous and responsible when we use it in critical situations.
I also think we need to be ready, if you kind of look at this picture behind me, for another cataclysmic open source event like Equifax Struts. I think it's inevitable. Is it going to be in a year? Is it going to be in 3 years? Is it going to be in 5 years? And that kind of leads to David's question. Hey, like, what should I do about remediation times, right? And so, get ready. There's going to be a really bad one in, maybe in 3 years, maybe tomorrow. And use the current vulnerabilities that are getting raised in your systems as an opportunity to practice and to really get that remediation time down.
All right.
Also, to David's question, I like Peter's suggestion in that to normalize, the difference between, there is a difference between proprietary or commercial code and obviously open source. But from a development perspective of how you build your services and application stack, to normalize practices around them, to have diverging practices for open source versus commercial versus proprietary, I think you're setting yourself up for a process and potentially a management nightmare. So if you can normalize as much as possible a practice for all of everything that makes up your code base and the stack that you build your services on, and that's kind of in response to David's question.
Curtis, millions of dollars is being allocated to help secure open source, so that's not a bad thing. But I guess my question is, are we ever going to be done, or are we always going to be spending millions of dollars on this?
I think we're going to be spending a bunch of money for a long time because we're digitizing. It's not, we are moving forward on this digital journey full steam ahead. So in correlation with that, I expect, to Julius's point, more struts, an acceleration of the incidence of these attacks. But with that, I think we'll get more adept to dealing with them. And that investment, I think now early stage, as people are taking on taking on the even large organizations, they're taking on the risk that comes with using open source code. I think it's a worthy investment.
Do you guys all seem to agree then that it might get worse before it gets better, or there's going to be this cataclysmic event? Everybody on board for that, or are we going to get lucky?
It's not a question of if, it's always a question of when something else will come up. But will it be cataclysmic? It's hard to say. There have been a lot of vulnerabilities that kind of did put us to a test. But I think transparency, admitting when you've made a mistake, like everything else, will probably get us a long way. And I think if the worst happens and you've done the best you could have done, I don't think anyone will expect that you should have done more. That's just the way I see it. Something will happen. Just always be transparent when it happens and do whatever you can to make it better.
In human society generally, Mike, I'd put it like this. In human society generally, a distributed model is always better than a centralized model in terms of risk mitigation.
Right. Julius, last question goes to you. Do you think that there's a difference between the quality of security that I might see in a small open source project versus a large one? Or do you think the bad guys are aiming for the large ones, or are they aiming for the little ones that they know they can get into?
I'm going to have to pass on that question. I just don't have insight into that. But if maybe Shiri would like to answer that one.
So again, I think the idea is more about processes, I believe, than anything else, right? In this model, like to the question before, like, is it better to have something that is centralized or distributed? Again, I think it's all of the above. But I definitely think that if we have the right processes in place, and if we have the right tools and the right culture, we can solve more or less everything.
All right, awesome. Guys, we're running out of time here. I want to get to our winners. They are Philip B, Shiva R, Christian S, and Michael B. Congratulations for all winning an Amazon gift card. I want to thank our speakers for sharing their knowledge and insights today. That was awesome, folks. And to all you attendees who've spent your time with us, we thank you yet again. Everybody have a great, safe, and secure day.
Thanks all.